Now, please welcome our next Tech Talk presenter, Dr. Amr Albana of Omega Wireless.
Okay, everybody had a good lunch? Can't see anybody here. So speaking to Seola, he said, we're supposed to give you a 15-minute nap. Oh, not today? Not this one? Next one? Okay, still, I really want you guys to take a moment and close your eyes. Close your eyes for me for a second. I want you to imagine a wireless network, a wireless system, DAS environment. We're getting approval for a DAS system. Does not take months. 3, 4, 6 months. Where your 3D modeling doesn't take days to build. Where your simulation does not take hours to run. Where your ROM is not delivered in an Excel sheet. And where your system and a stadium does not cost millions of dollars to build. Nice thoughts, right? Very happy thoughts. I want you to open your eyes. I want to tell you that we were able to do this with AiON, AI optimized networks. We were able to deliver approved designs in weeks, not months. We were able to build 3D models in seconds, not hours. We were able to run simulation in milliseconds, not hours. We were able to give a ROM design with real propagation results and antenna placement, not just merely an Excel sheet. And we were able to bring the cost down of stadiums and venues from multi-million dollars to sometimes under $1 million. How did we do that? Let's see. All right, so to give you a quick background about us as a company, we've been around for over 15 years, been involved in so many NFL stadiums, Super Bowls, high-capacity venues. We specialize in delivering complex systems, complex networks, complex challenges with a lot of traffic, a lot of users, being an NFL stadium or a Formula One or a Disneyland. We have been involved in so many pieces of the cycle of building a system to the point that we have inserted AI in every single step of the way. I myself have been in the industry for about 30 years. About 20 of these, 25 of these, were still doing AI before AI was cool. Now it is cool. And we've done a lot of research, a lot of patents on that. All right, so what does AiON do? What does it mean? What are some of the features that we've just added recently? We suffered through building these systems, designing and optimizing these systems. And we took it upon ourselves to build modules to serve the design cycle or the design optimization and build all the way from the inception, all the way to turning up. So we're going to start with the first one, AiON XD, where we're turning 2D images into very accurate 3D images. Most of the time you don't have CADs. We're going to talk in details about this one. The next one is AiON ROM. You're not delivering your ROM designs in Excel anymore. You're actually going to be able to build it very quickly and very efficiently. AiON Save, where we were able to save tons of money by designing the right radius, the right capacity, and calculating throughput, just enough to deliver to the customers the best experience possible. AiON-IPS is where you get simulation results in seconds, not in hours. I'm going to show you the example of that as well. And last but not least is the AiON RAB. That's a new module that we've introduced, where you turn up the system. It has nothing to do with your IB wave design. Does that ring a bell? So you have one of two choices. Either you go in the field, look at every antenna, audit every single element, or what we were able to do is to use the walk test that you have after turn up and make sure everything makes sense. And it matches what you have in the IB wave design. Yes, and not to forget the AiON Pro, which is basically taking all these algorithms and calculations and come up with better throughput. We've also been working very close with Ericsson to build AiON real-time into an R app, as well as working with IBWave to streamline the process. Make sure that we have easier way of taking these designs, building the digital twin, and delivering on these designs. All right, so typical design cycle. You pick a big stadium, pick an antenna, change the tilt, let it run. How long does it take? I think we've shared this last time. It could take up to an hour just to change one element parameter and see what the results are in terms of RSRP, SINR, and so on. So this was very time and cost prohibitive for us to optimize around. So what we did is we built our own engine that will build a digital twin, run the optimization, or actually run the calculation in a fraction of a second. And this year, we're able to run this also in the cloud. Last year, we showed you our desktop solution. This time, you can access it from anywhere. So if you're, a lot of you have used our service and in the past, we'll be able to take that design, give you a web interface where you can actually play with the antenna. You can pick an antenna, you can play with the tilt, you can play with the azimuth, you can play with the power, and you can see the results instantly. So by the time you will run one calculation on a conventional design tool, you would have run through thousands or tens of thousands of calculation with AiON. And that allows us to be able to get to that real global optimum much faster. So at least you'll be able to calculate that. What we've added in our tool also is the capability to be able to do a delta plot. If I change this antenna or tilt or power, what's going to happen to my coverage? What's going to happen to my throughput? What's going to happen to my SINR? And you can always play with your best server, play with your settings and antenna configuration and so on. We also added another feature to be able to have like a probe that displays all the details of where you're going, what antenna you're touching, and so on. All right, so this was what we shared last year. This year, we're adding a few more modules. The first one is kind of interesting. A lot of times, especially for enterprise, you get JPEGs or pictures or PDFs of CADs. You don't always get CADs. And that's a big challenge because it could take 10 minutes, 15 minutes, 20 minutes. In this case, in a conventional way, you put the picture and you start tracing the walls and build the doors and windows and so on until you get to a 3D model. So we utilized AI to actually do the same thing. So we're going to open the picture and we're going to convert it in 1, 2, 3 seconds. And it comes up with a DXF file. And that DXF file recognizes walls, doors, and windows in a few seconds. Now that DXF file, you can take into any design tool or any CAD tool, you can play with it. I want to say it's probably 90 to 95% accurate. As you can see, we recognize all of it. So what used to take us hours and days maybe to build a 3D, this will be a matter of seconds or minutes and you're done. So that's the first breakthrough this year. On the next slide, we're talking about how we can use AiON to do ROM designs. So basically, you can build a project, import the project, you can start putting antennas, put the walls, start running prediction. You can move the antennas around, get an instant response or instant calculation that shows you where you are. You can change the tilt or azimuth, obviously. You can add more antennas. Run the prediction. You can even calculate your RSSI, RSRP, SNR, SINR, throughput, which is very important, as well as CCI. And you can optimize those. You can change the channels and get better results on the throughput. So this is if you want to do the interactive I want to say enterprise designs. Now, we said, well, this is great, but how can we use AI to automate even that? So with this, we're able to, with the AiON ROM Automate, we're able actually to build a design. I mean, if you want to do this in a design tool, you will be placing antennas, you're going to be turning them off, turning them on, moving them around, so that you can achieve the minimum number of antennas that satisfies the threshold of coverage. On our side, we're able to load the 3D model, place all the antennas, and let AiON itself try to move the antennas around. You're going to see a little bit of action here, changing the antenna locations, turning on and turning off. Instead of having 12 or 15 or 20 antennas, you'll end up with probably like 8 or 10 antennas. So what is that number of minimum antennas that I need to cover above, let's say, NIC 85, whatever that threshold is? The other thing also is, this is an exercise that we did with AiON Safe. So this new module, with this new feature, allowed us to work with one of our partners in the room today. We worked with them for several major markets. And for Super Bowl event, especially for the outdoor area, we were able to reduce CapEx by almost 33%, while at the same time improve the throughput by 11%. So who said that you need that many sectors? Who said that what you have is too much or is it too little? What is the right value? How can we, instead of adding more sectors and more equipment, just optimize what you have and get better results out of that? A very similar exercise we did for one of our partners, one of our 3POs. They're here with us today. And we were able to actually reduce the number of radios within that little arena. We were able to bring the total cost of the system from $2 to $3 million to under $1 million. This was triggered by the fact that when AiON optimized, it said, well, you have a lot of these antennas or all these sectors are overshooting or has a lot of power. What can we do to reduce this power? If I reduce power, I can probably combine radios. I don't need that many radios. So you can combine 2 into 1. You can combine 4 into 1 sometimes without reducing your coverage. And with that, we were able to bring the cost down significantly. Now, what that means to 3POs and even the carriers is you'll be able to build more venues. You'll be able to sign up more carriers on your venue. You make it more affordable to your customers, and you make it more reachable. I think we talked about cellular and Wi-Fi as part of our new AiON module. And over here, we were able to take a concert hall with one of the 3POs. Basically, what we were able to do is to get Wi-Fi network to improve dramatically. We improved almost like 100% on the throughput, while reduced the number of APs by 30%. You don't need that many APs. They're causing more noise than they're actually causing more capacity. So where is that threshold? Where is that right number of APs that delivers that kind of quality? Very similar on a major airport on the Northeast, on the Wi-Fi network, we were able to improve throughput by 50%. And what you're looking at is the before and after in terms of the throughput. And you can see a lot of these terminals are getting way better performance. All right, so to recap, with our new suite of tools with AiON, we're able to touch the system build process every step of the way. From the inception, from the ingestion of the 3D models or pictures or CADs into getting an initial ROM design or automated ROM design, trying to save on the design, giving you just enough sectors, just enough equipment, just enough configuration to serve the throughput that you want to deliver for your customers, whether it's a FIFA or LA28. We're involved in all of these. We're able to give you insights in seconds, not in hours, with the IPS. And we're able to use AiON RAB to reverse engineer and build your as-built for the next steps. And of course, we can use the AiON Pro to optimize the whole network. I'm really looking forward to your comments and your your feedback. We have a table that we will be doing a few demos here. But I really want to thank you guys for your time and your attention. Oh, great! The QR code showed up. Okay, you guys can actually scan that QR code, and you can set up a time to have a more detailed discussion. Thank you so much. Appreciate the time.